I'm back, stupid mistake, I found it. Here it is, right here. I said 8 minus 8 thirds. I converted 8 to 24 thirds, but I didn't keep my 8 thirds, my negative 8 thirds, I just left it. So, yeah, that's a big mistake. Don't do that. And I know my color codings are all off, guys, sorry about that. So, this would be 9 thirds. Get rid of that. 9 thirds minus 16 thirds. Yeah. I was looking back over here and I put 20. Okay, so yeah. That makes sense. 9 thirds minus 16 thirds. 9 minus 16 I think is negative. I don't want to mess this up. Negative 7 thirds. I know a math teacher can't do it in his head here. Yeah, that's right. Negative 7 thirds. And so that should be positive 7 thirds. The absolute value of negative 7 thirds is positive 7 thirds. And so therefore, answer here, 23 over 3. Okay, so 23 thirds is our answer. That is the area under the curve. Now to kind of wrap this up, guys. So what we found here, let me go all the way back up here and let me label this. So that area was 16 thirds. This area is technically negative 7 thirds. But if they want the area under the curve, area between the curve and the x-axis, you need to make both of those positive and add. All right? So take the absolute value is what we mean. So if I would have just done this, guys, if I would have asked you, let me just write this down. Here, let me actually flip pages so I can just flip back and forth here. If I would have asked you this, what is the integral from 0 to 3 of that function, which was 4 minus x squared dx, what would our answer, what would that have been? Well, it's not going to be the answer we got here. The answer that we would have gotten would have just been to subtract these areas. So it would have been 16 thirds minus 7 thirds, or plus negative 7 thirds. And that would have given you, isn't that just 9 thirds, which is 3? So that area would have been 3. Okay, I want to make sure I'm doing that right. 16 minus 7, yeah, that's 9. 9 thirds. Okay, so it'd be 3. So again, I want you to recognize the difference. This would have been, if our function would have been, if our question would have told us to evaluate this, the answer would have been 3. But since the question worded it like this, find the area of the region between the curve and the x-axis, we have to do that process. So let's write down that process. This will be the last thing. Here we go. Got it for you right here. To find the area between the graph of y equals x and the x-axis over the interval from a to b analytically, you partition a, b with the zeros of f, you integrate f over each subinterval, and then you add the absolute values of the integrals. So pause that there if you need to write this down. You probably should. I'm going to go back and talk about what we did there. So this is what we did. We did part 1. We partitioned it with the zeros of f. So we figured out where the 0 was. It was at 2. So we broke it into 2 parts. Now, if it crosses, if it crosses back again, if it goes back and it wants you to find, let's say from 0 to, I don't know, 7. If it crosses back, you're going to have more than 2. You're going to have to find 3 integrals, or maybe 4, maybe 5. Depends on how many times it crosses the x-axis. Depends on what your interval is. So yeah, you just partition it by your zeros. So we went from 0 to 2 and 2 to 3. We broke it up like that. And then we integrated over each subinterval. Okay, so you got to integrate there. And then we got to add the absolute value. So if you get a negative area, make it positive and add. Okay, so that's all there is to it. All right, that'll wrap up this final video on section 5.4.